Here we're going to look at a hint for part 2 of the 1D forces activity where the friction force is on. And in this case we'll look at the refrigerator, which has a mass of 400 kilograms instead of the file cabinet. But the idea will be the same. So I'm going to go ahead and press the go button here, and then I'm going to just gradually increase the applied force on the refrigerator. Slowly increase it until it starts sliding. Okay. And then once it starts moving, I'll stop increasing it. I'll just hold it there for a little bit and let it run for a little bit and hit the pause button. Okay, here we can see that as the applied force increased and increased, the friction force always matched it, so that the total force here is shown in green, the total force is 0, giving 0 acceleration. But right at this instant of time, which is roughly about 5 seconds, right here the applied force reached the maximum static friction force, and just as the applied force exceeded that maximum value, the crate started moving, or the refrigerator started moving. All of a sudden, once it started sliding, the friction force now is kinetic friction or sliding friction. Kinetic friction is typically less than the maximum static friction force. In this case, the maximum static friction force is about 800 newtons if you look at it carefully, and the kinetic friction force in this case is about half that, which is around 400 newtons, rounding off. Okay, 392 newtons. So that's maybe a little bit of an extreme difference between static friction and kinetic friction in this example, but typically the sliding friction or kinetic friction is less than this maximum static friction value. Now, just another thing we can check is that here the acceleration is 1.2 meters per second squared once it gets moving. We can figure that out using F equals ma, or the net force is the mass times acceleration, by looking at the net force as being the applied force minus the friction force. So 857 in this case minus 392 gives me a total applied force of 465 newtons. Okay. Now if I divide that by the mass of the refrigerator, 400 kilograms, I get an acceleration of about 1.2 meters per second squared. So that's how everything should fit together for you.